Hello, ladies and gentlemen, and welcome back. We're looking at question number 9. We are just over the halfway mark on our 2011-2012 Alberta math contest. A lucky number is a positive integer n so that 7 is the largest divisor of n, which is less than n. The number of lucky numbers is... Okay. So 7 is the largest divisor of n that's less than n. So I know n has to be 7 times something, because 7's got to be a divisor, right? Okay. Now, this k here, k can't be bigger than 7. Otherwise, k would be a factor of n. And it would be bigger than 7. 7 needs to be the largest. K can be less than or equal to 7. And I do say equal because if k is equal to 7, n is 49. The factors of 49 are 1, 7, and 49. 7 is the biggest one, less than that n. So that's one of them. Okay. So I guess we could have, these are kind of limited. So we could have k, we could make a little chart here. Well, if this were bigger, if it was something like prime number 71 or something, we might have to do a little more thought, a little more work, but we could just check the values of k. We know 49's fine. 7, 14, 21, 28, 35, and 42. Can we think of bigger factors of 7 in here? Well, yeah, 14's a factor of this one, and 14's a factor of this one, too. But for 35, 1, 5, 7, and 35. 7, unfortunately, the biggest factor of 7 needs to be not the number n itself. Less than n. So that one's out. But then 1, 2, 7, 14. 1, 3, 7, 21. These ones work. So 1, 2, 3, and 4. So there's 4 of them. I think that was answer D. 4, okay. Now, if we were going to do this a bit more in depth, and the question's done. So if you want to move on to question 10, like, subscribe, blah, 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 blah. But what's really going on here, we need n to be what's called a semi-prime. It needs to be 7 times another prime. Now, why is that? So imagine k was a times b, where a and b are both bigger than 1. Well, then 7a is a factor of n that's bigger than 7. Well, we can't have that. So we've got to have 7 times a prime. Okay. So what we're really trying to do is count the number of primes less than or equal to 7. Those are the only acceptable values of k. So that's how you'd approach the question if they weren't asking about, lucky numbers with 7, but lucky numbers with 71. We would need to count the number of primes less than or equal to 71. So here with 7, how many primes are less than or equal to 7? 2, 3, 5, 7. And look, those are exactly the values of k that worked. Okay? So that's more of what's going on there. Is that there's a reason that only this primes worked out, because if you had k as composite, as we've seen, 4 is 2 times 2, 6 is 2 times 3, 2 times 7 would then be a factor that isn't n. Okay? So, there we go. That's question number 9. As I said, question number 10 coming up next. I'll see you for that in the following video.